Welcome back to the DASYLab training. This training will make the most sense if you have watched the previous modules.
Module 7 will be split into two parts to be able to keep each video under or about an hour. Part 1 will talk about documenting DASYLab, averaging data, and separating data. Part 2 will talk about multiplexing data, the new SmartMux feature, and the signal router and signal switch modules. We'll start off by talking about how to document DASYLab. Use DASYLab features to self-document the worksheet with module names using channel names, units, and descriptions. This is the easiest thing to do because you can do it as you're creating your worksheet. You can use the work area documentation features that are shown on the right in this image where it says this example shows a simple oscilloscope. That's a blue block on the background of the work area with text information in it. You can then save the worksheet as documentation as a text file or an HTML file. And then you can save an image of the worksheet. You can do a print screen, you can copy to clipboard, you can print it, depends on how you want to do it. And then you can separately describe the function of the worksheet. There is a worksheet info block that you can fill in, but when you're documenting, you also need to document your overall system. All I can do is talk to you about documenting the DASYLab component of it. So we're going to take an existing worksheet. We'll customize the modules. I'm going to use the data logger worksheet that I was just doing with a custom file name. I'll customize the modules. I'll add module names, channel names, descriptions, module documentation. I'll add worksheet documentation to the worksheet, and I'll add worksheet info. And then I'll show you how to save it as documentation and to save it as an image. One thing to note, the DASYLab evaluation version will not allow you to save the worksheet as documentation, and that is a limitation of the 28-day version.
I've opened the data recorder data logging worksheet that I had worked on in the last module. And what I want to do is show you documentation. And I'll start from where I should have done it with the analog input. First, open up a module, open its properties, and you can give the module a name. This is going to be an MCC USB 201. You don't always have to be that specific, but it helps when you're looking through a worksheet to know what it was created with. You can give a description. This is my USB 201 for training. So you can give a short description. Neither of these are particularly long. A short description. And then for each channel, you can give it a channel name. Now, modules that originate channels give you a channel name, blank area, and default to some setting. The measurement computing driver defaults to AI0. And so this is going to be my function generator. And this is going to be a null channel. There's no data, so null 1 and null 2. So these are data that I'm collecting that I know there's nothing connected to. When you're looking at the settings for each device, measurement computing is keeping track of things like the type of sensors available on the device. This is a voltage-only device. And it allows you to change units here, even though it's only reading voltage. So I would like to urge you to change the units when you get to the scaling module. The limits are specific to the device. This device is a plus or minus 10 device. It is a fixed voltage range to read in. Other devices will allow you to read in different ranges. So I have documented this module. Now you notice when I hover over it, let's do that again. When I hover over it, it shows me a quick tag that gives me the information that's inside the module. It says MCC USB 201, and then the description that I put next to it, my USB 201 for training. If you need more documentation for an individual module, you can right-click on it, and at the bottom of the dialog box, there's a module documentation setting. You can open this, and we're going to give you 256 characters to describe this. So this is an 8-channel USB 201 with a function generator connected to channel 0. So I didn't use anywhere near 255 characters. Now, when I hover over it, you're going to see the name, the short description, and now the longer description. You can do that for each module in turn, but let's look at the scaling module first. The scaling module, when you look at the channel name, it's initially grayed out, and there's a checkbox next to channel name. By default, DASYLab wants to copy channel names from module to module. It actually doesn't enable that initially, but it allows you to do it. So the concept is that the channel name will start at the origin of the data and stay with it until it's transformed in some way. So this is the scaling module that I created that is multiplying by 2 with an offset of -1, and I called that PSI. I can give this a more descriptive name, Scale Engineering Units. Scaled Engineering Units doesn't give me enough room, and then I can give it a longer description in the description box. I've already given it a unit so that I have documented in that way already. Now when I click OK, the channel name that was in here was still the channel name associated with the default module. In order to get the channel name from the MCC USB 201 module, I can go to the Options menu and click Copy Channel Names. Now when I open the properties for the scaling module, you're going to see that in light gray, we have got the channel name that I had created in the origin module. Next, I can go to the digital meter and go to the module properties. I can give this a unique name as well, so this can be my digital meter scaled data. This is my scaled data display. DASYLab does want module names to be unique. You can see the copy channel names also copied the name into the digital meter. Now in this module, the unit has a #0, and the #0 tells DASYLab to take the unit off the channel connection. So the upstream module, the USB 201 and the scaling module, will include the unit when it sends the data to the next module to be processed. #0 allows you to just pick up the incoming unit. If you were doing a function like an arithmetic where you were dividing one channel over another, you would see the notation here would show that operation in the unit. And if it's appropriate, then the unit would be transformed to the unit appropriate to that channel divided by the other channel. In the case of volts divided by volts, you would get unitless. So volt over volt. So we have done that. We can also do the right-click module documentation on these. So we can give you a brief description. And then again, you get to the recorder, go to module properties, and then this is going to be a recorder. Let's just do rec scaled. At some point you start abbreviating. Chart the scaled data. Again, this is picking up the channel name from the copy channel names and the unit from the channel itself. So we've got 4 of these modules named, and now the right module, again, it will have copied the channel name, and we're going to write to CSV save as comma separated data. And click OK. And because this is the complex thing, this would be a place where you could say file name is composed of strings. So this would, if you hover over it, you can look at it and you can see that piece of information. The other thing that you can do is you can go to the options menu and go to global settings. And in the global settings, in the center right, is a copy channel names when measurement starts. Check that box, and then DASYLab will automatically copy channel names when that measurement starts. You don't have to remember to go to the options menu and do it every single time that you change a name. So this hasn't changed how DASYLab runs. This worksheet's still going to do its thing. The next step on documenting is going to be creating document descriptions on the back of the worksheet so that you can describe sections of your worksheet or provide other information that you want to include on this view. You would create that by doing a right-click, select Edit Documentation Frame. That changes your cursor to a baby crosshair and a piece of paper, but it doesn't do anything yet. Now right-click again and say Create Documentation Frame, and click and drag a box. DASYLab is going to create a rectangle the size that you created. If you put your mouse over that, right-click, and go to Documentation Frame Properties, you're going to have 256 characters that you can include here. So this is a data logger for the function generator, created on, what is today's date? This is the 18th. I can fix my spelling. It's going to default to this color. I gotta fix everything now. All right, so it defaults to this color and it defaults to this font. You may have noticed that there was a button for font. You can, for example, go to a bold italic font of 16 points and click OK. Click OK, and you've got a heavier font. It's more readable. You can go back to the frame properties. You can change the text color. You can change the background color. Say you want it to fade in a little bit more, so you can pick that yellow and it will fade into the back. Oh no, never mind. It didn't fade in, did it? You can pick a variety of background colors. This DASYLab background is this yellow hue, so white will still stand out against it, but it doesn't jump out the same way. You can change the size and move this. If you put the crosshair of the cursor on the lower right-hand corner, you can drag the box larger, and note the box is behind the modules. You can drag it smaller, and if you don't like where it's positioned, you can click anywhere in the box. It will anchor to the upper left, and then you can drag it around. You can create multiple frames. It's going to default to that blue color. It doesn't matter where they are or whether they overlap. So I can create an overlapped frame if I wanted to. Edit, create. So the most recent sits on top of the previous. So it's going to be the order that you create them that determines how they sit on the screen. If you are like me and just nuts about having it line up, you'll sit and fiddle with it until you get it to line up. And that ends up being a technique that you work with. So that's the documentation frame. It allows you, let's just show you an example. I can take this box and grab its lower corner and make the box that big. I can take this one now and make it this big. So I can describe each section of the worksheet. Documentation frame properties. This is going to be the MCC input module. This is going to be the display modules. When you open up our example worksheets from the help, you should see the same thing, that we've done documentation frames to try to explain what the examples are doing. All right, let's fit this. Takes a very fine touch. And then the documentation frame properties, save data to the hard drive. Even just a simple explanation like this is enough if somebody picks up this worksheet after you've done with it to understand what you've done. If you have a much more complex worksheet, as most of our customers end up doing, the more you can document on the work area and in the modules themselves are really going to help out your successor. So you can think of it as either a job security plan to not document or a personal improvement plan to be able to move to another job and never have to look at that project again. So let me create one last one just to show you you can use this in a variety of ways. You've got 256 characters. So to set up this test, do the following. So you can give instructions here for your user and have a list of things for them to do as part of setting up the test. So that's good. Now I'm finished with that. I can right click and turn off the edit documentation frame. So now I'm cursor's back to the normal arrow cursor. If I double click on any one of these, I can still get to the properties. So for example, I don't like the frame. I'm going to make the frame white. I just want it to blend in as much as I can. Once upon a time, I figured out the best way to figure out what color this yellow is, because it's not on the normal palette. I went to the colors. I right-clicked on the worksheet. I went to the colors for the background. I went to custom colors, and this color is selected. And I clicked on a custom color. Well, that didn't work. Let's do that again. Custom colors, and I added it to the custom colors. So now that light yellow hue is a custom color. Click OK. Now I can go back to this documentation frame and go to the background of it, and I can select that custom color, and I can have it blend right into the background, and only you and anybody else who's used this feature in DASYLab knows that that's a documentation frame. Your frames can be different colors. Clearly we've shown that, but just to give you the example, so you can go to a green, and I always think that's too dark. So I'm going to take it into a slightly lighter hued green that doesn't have, there we go. I don't want the neon color, but now I got the neon color, didn't I? So you can have these be different colors to be able to identify different areas of the worksheet. So, reviewing, module names, channel names, units, module documentation, module descriptions, and now worksheet documentation or work area documentation. Now the next step with this is to describe the whole worksheet in some place that you can go back to when you need to. If you go back to the File menu, there's a Worksheet Info selection. And this Worksheet Info selection is also a shortcut button next to the time base and hardware settings. If you click on Worksheet Info, you can enter the author name. It picks it up from when you installed it. The company, so DASYLab. The department is DASYLab Sales and Support. You can give this worksheet a title, 3-channel data logger, and this worksheet demonstrates the Combi file name feature for custom names. It also shows documentation. It also shows you the date it's created and the date that it was modified. So I had worked on this yesterday with the video, and now I'm modifying it today. Click OK to save that information. You can have DASYLab always prompt on a given system to display that information. In the default settings, you can say show information when loading a worksheet. So if I click OK, I'm going to save this with a new name. So this is the data logger with a custom file name and documentation. I'll close DASYLab. I will reopen DASYLab. I will load that worksheet. And you can see now it prompts me for the worksheet info or with the worksheet info so that I can see what this worksheet was. So that's a system by system setting. That isn't a worksheet setting. So if you always want to be able to look at the worksheet info, you would configure that in the global settings. Now, I said that we can then save this as a file. So if I do a file, save as now, I can save this as a worksheet documentation, a .text file, or an HTML documentation. I'll do both. Let's save it as a text file. It's going in the worksheets folder. Click Save. Then I'll do it again and do Save As. And this time I'll save that same one as an HTML file and click Save. Now I've got to go fish it out of that folder. So now I have a folder where you can see that I have my data logger with custom file name DSB, HTM, and TXT. Let's look at the TXT file first. I'm going to open it in my TextPad editor, which of course opens on another screen. Let's bring that in here. My TextPad editor allows you to see that this is a outline formatted file where it's got a begin and an end block to identify each block. So the comment tells me that this was created with DASYLab 2020.1, the release number, the build number, and the build date. So 2020 Service Pack 1 is really new. The information that I just entered in the information block is stored at the top. The experiment setup, this is the original driver settings, the legacy driver settings, which on this computer are set up for a kilohertz with a block size of 512. I have the global variables and strings defined that we did as part of Module 6. So I've got the work order with the text, the name of the actual file name, and the place where the file went. I don't have any global variables defined in this worksheet. This worksheet has 6 modules, and then we've got a description for each module that includes the text information, so the description, the documentation, and the channel names, as well as the information that the driver needs to be able to work with this module. So this is the information that helps measurement computing know what the device was, and device 0 is a USB 201 with no other devices connected. Module 2 on this list is a scaling module. Again, the documented, you can read the text information, and then it's got the values associated with each channel. It's if this module had used global variables, what would they be? Are you using bounds? Are you using interpolation? Are you doing cold junction compensation? So these are a lot of settings that we didn't even see that are tucked into that function. Digital meter, same thing. Chart recorder, more concise than the scaling module was. And the right data module giving us all the information of how the data is going to be stored in the file. At the very end of this file is a list of the time bases that DASYLab knew of when you saved it, and any global worksheet settings that you may have done. So this is a straight text file. You can print it, save it on your hard drive, punch holes in it, put it in a binder. You can't open it with DASYLab, but you could use this information to recreate a worksheet if you needed to. The second format is the HTM format. And the HTM format opens up in Chrome on another screen. And again, this is the same information formatted differently. So this may look better when printed because it's got frames around all of the module settings. It also has hyperlinks so that you can jump ahead through the worksheet and see the different modules that are connected to the one. You can see that you've got the description information here, save as comma separated data. It's got the channel name. It's got the actual string that we use to create the file name. And the other information that was in the text file is up here at the top so that you can see you've got, again, a file. You could print this, punch holes in it, save it on your hard drive, save it with the data. There's a slide I've never made, and that slide says backup. DASYLab is a software program, and like other software programs, sometimes things happen. Your computer, the power goes out, your computer crashes, something glitches in the program itself, and the worksheet becomes unreadable. Your hard drive glitches. We do have people who've been using DASYLab for a long time, and we often get calls saying, hey, I'm reinstalling DASYLab because the hard drive failed on that computer. And they're looking for some assistance. So back this stuff up, back it up on a place that is not the computer that you're running on, particularly once you're done, certainly while you're working on it. But once you're done, please make sure that you have it backed up to some other media server or another computer. Thinking about backup takes me into another topic too very quickly. Options, global settings. When DASYLab starts, by default, it will create a backup copy at start. If you haven't made any changes on this setting, it's creating a file called last.dsb, and it will make one copy. So each time you hit start, it will overwrite that backup. In DASYLab 2020, we changed this setting so that you can now specify how many backup files you want in your file history, and you can specify to use the actual worksheet name that you're working with. So that's another way to do a backup. It's not quite the same thing. I still want you to back it up off the computer, but if you make a change and realize that that was a mistake, you will have a backup file on the hard drive to be able to look at. And if you look at my worksheet folder, you can see that I have the data logger with custom file name ~00 and ~01 as I was working with these worksheets. When we were working with the FFT example for module 4, or module 5. It was one of the previous modules. You can see that I've used all 5 of these file names. The most recent one is 0, and then it will rename the previous ones so that you always have the previous 5. Okay, so the last part about documenting, having backed up now, is to take a picture of this. You can go to the Edit menu, and you can say Worksheet to Clipboard. And I will open up my handy-dandy screen capture program. Which currently says, welcome to Snagit. See if we can get this in the screen. All right, so we have my Snagit program showing in the screen. And I can do a file, new, from Clipboard. So I can take whatever is off the clipboard and put it into a file. I could just as easily have pasted that into a Microsoft Word document. Let me get Word open and make it small enough to fit in this screen. Bring it over. So I can do the same thing here. I can do a paste, and now I have that same information. So I can do the copy to clipboard. We have improved some of our graphics, so this should scale pretty well. The font is not pixelating as it gets bigger. So we have done a better job with the graphics than we had done in previous releases. If you don't have a previous release, don't worry about it. And the last thing that you can do with the worksheet is you can do a file, and from this view, you can do a print. And it's going to default to my default printer, which is also the Snagit program. And so what this will do is it will print on the sheet of paper, it will try to fit the worksheet, and it will include the descriptive information that I had included with the worksheet. You can control in the File menu, in the page setup, what information you would like to include. And so you can include more information. So this is a short header comment, and this is a footer comment. So now I'm going to click OK, and I will print it again. And it will pop up in the middle of the screen, and now I have that header comment. You see the short header comment, and that it includes the context of me, that it's CJ Butler, DASYLab Sales and Support at Measurement Computing, along with the name of the worksheet. So all of this is to say, we're not going to do the job for you of documenting this program, but we're giving you the tools to be able to provide documentation for it. And one of the reasons I talk about it toward the end of the class is because at the beginning of the class, you're focused on learning the program. Toward the end of the class, you're starting to think about how you're going to use it for the project that you want to work on. And the most important thing that you can do is ensure that if you come back to this in a month, or in 6 weeks, or in a year, you can understand what you did. And documenting it in the worksheet, creating the appropriate files for a project that you're delivering. You built a test stand, putting all that information in one place, either in a folder on the computer or on a USB memory stick, in a way that you will be able to read it. I always visualize printing as much as you can, punching it, putting it in binder, and gluing the binder to the side of the test stand. That may also include the schematic. So none of this is talked about your physical, mechanical environment or your electrical environment. That should also be part of any documentation that you do. One last thing on the worksheet documentation, the work area, this is text only. Sadly, we can't get images into this. That would be the best part, I think. But I do have customers who have taken layouts and created a layout where they have created images and been able to include information in the worksheet that helps document some of what the test is about. So you could put a bitmap here that describes your test. What did we have for examples? PNGs? Nope. JPEGs? GIFs? Oh, GIFs would be terrible, wouldn't it? Once upon a time, we had a great schematic. We appear to have lost it. So you could put, as part of the description, an image that describes what you're testing, and then you can conceivably include instructions here, so you could make a text box that gives you instructions for how to set up with this. I always hate the font in this. It's too small to start. So that's the documentation topic. Please use it. Please take advantage of it. Please use channel names. Please use module names. Please keep your module names unique. Then you can figure out what it is that they're doing.
Now we're going to talk about managing data. There are a couple of different ways to reduce data in the DASYLab worksheet. If you're collecting data at a higher sample rate than you want to save to the hard drive, or you need to reduce data to be able to do a PID control, or for any other reason that you want to reduce the data, we've got three basic functions. One is the average module, and that's in the data reduction group, not the statistics group. And we've got a separate data function, which is a keep one, throw away 9 kind of function where you can reduce the data and you can define the initial settings and the running settings for that. And you can also use a relay to remove unwanted data. So for example, just a simple switch relay to control your data flow. When the switch is closed, there is no data. When the switch is open, the relay closes. You can use a relay to remove unwanted data. For example, a switch and a relay combination, when you click the switch on, the relay will close and allow data to flow, and when the switch is off, it will prevent the data from flowing. So that's another data reduction technique. I see this often used in combination with people only wanting to save data on demand and not constantly. Managing data also means managing channels, and I'll look at the signal router, the signal switch, and the multiplex demultiplex function. So the first example we're going to work on, we'll use the data logger worksheet to average the data. And what I want to do while we're working with it is compare a fixed average and a running average. And we can do them side by side, and you can look at the results of the data. I want to make a note here, I'm not using the block average module. You would use the block average module to average FFT blocks, not normal time-based data blocks.
Starting with the data logger worksheet that I created, I'm going to add in the data reduction group an average module. And what I want to do is insert the average module in between the analog input and subsequent data processing modules. It doesn't matter where you put it. It only matters in the context of your worksheet. What does your logic need? This worksheet is sampling at 1,000 samples per second. If I do an arithmetic mean on the data, that means I'm adding the values together and then dividing by the number of values. We've got three interval structures. One is fixed. So this is a fixed vector of samples that will be averaged each time, and one value will be output. A moving will move a window over the data, and the output will be the average of the previous samples. And then the next output will be the average of the previous samples. So it will include the new sample and drop the last or the oldest sample. Cumulative does a cumulative average. So as each sample comes in, it will output the next value based on the average of all the samples. You can specify the interval width. So say we average down by 100. So if we average down by 100 samples, we need to do some mental thinking here. I'm doing a fixed average. Every 100 samples that come in are going to go out as 1. My incoming block size is 100, and without any other settings being changed, it will wait for 100 samples to fill up that block. So when you downsample, you also have to think about your input and output block size. So doing a fixed interval structure is downsampling by 100 values, and I want to tell DASYLab to change the block length at output to 10. So I am reducing the block size by the same ratio that I am reducing the number of samples. So if the incoming block size is 100, the outgoing block size is going to be 10. The next thing to think about is, what do you want the timestamp on the data to look like? Do you want it to be the timestamp of the first value that you've averaged or the last value that you've averaged? This is going to depend completely on your own application. This is an example of a module where all of the settings are underneath the channel bar. That means when I look at channel 1, it hasn't been updated, and channel 2 hasn't been updated. If I go back to channel 0, and if I click the function 8 key on my keyboard, all of the settings will copy, including the channel name, but the channel name is grayed out, so the channel name should be picked up from the channel that it's connected to. It's picked up arithmetic mean 110 and the change block length, and channel 2 is the same way. Click OK, and now I want to add this in, and it means I'm going to have to fix my my documentation too. So I want to disconnect scaling. So I'm going to delete the input connections, and I'm going to slide everything to the right. And then I will wire the average module in. And if I really am going to care about the documentation, I'm going to take a second and fix it now. To fix the documentation, I'm going to right-click, turn on Edit Documentation Frame, and then I am going to move the documentation frames to the right, and then increase the size of the MCC input module. And increase it a little bit more. And display modules can go a little bit more to the right. There we go. And saving data to the hard drive. So you can see this is a little fiddly, but it still works. Once I right-click and turn off Edit Documentation Frame, I can rearrange things so that they fit nicely. I can edit, I'm double-clicking to edit the MCC input module with average and scaling. So I'm keeping up with my documentation as I go. The module could use a module name, so average is kind of obvious, but if I say -100, you'll know that you're averaging over 100 samples. So the next thing, I'm just going to double check and do copy channel names. And I'm saving the data to the hard drive. I have previously entered, let me hit start. I previously entered separate and average to be part of the file name. And so now on the chart recorder, I had previously displayed the name of the file that we're actually creating. So this is going to be 2020-12-29 separate and average data.csv. So as I look at the data coming in, it doesn't look that different. It looks like it's updating at a nice pace, but I do want to double check my settings. The output of the average module is a block size of 10, a sample rate of 10. So I really wanted a block size of 1 coming out of the average module. It's updating every second right now, so it's a nice stately pace on the screen. I'll quickly hit stop. I'll go to the average module, and I'm going to recognize that I don't always remember the settings or do computations well in my head, so I double check it. Change the block length at output to 1. I'm going to click the function 7 key, F7, to copy that setting to the other channels. And I always click and verify it. I'm going to keep separate and average as the file name. So I'm on file name, and now it's updating every 10th of a second. So it's looking a little bit less stately. Part of what you can see with these settings is, let's make this bigger and zoom in a little, that sinusoidal waveform is a little choppy now. It isn't quite as smooth at this sample rate. If I increase the frequency of the signal, now you can see that averaging is taking out anything that makes it look like a sine wave. It's actually turned it into a triangle wave. So I just increased the frequency by 10. Now if I muddle around with it a little, depending on the frequency of the signal, averaging is going to start to distort the data. You'll lose the frequency, the waveform component of the signal. With a slow signal, so let's go back down to slow, you still retain some of the original signal. And if I slow it even further, going back to the slow signal that I was looking at, you can see that at the very slow frequency of this signal, that I can see it more clearly now. So the averaging that you're doing is going to depend on the underlying frequency of your signal, whether you need to retain that or not. And if you're trying to get rid of, say, a 60 cycle signal, you've got a fairly flat, slowly changing temperature signal or something like that, then you can easily do that. If I make this 60 hertz, so now I've got a 60 hertz signal that this average is pretty much removing. It's taking most of the amplitude associated with the frequency signal and reducing it. So now it's sitting at a baseline of about negative 0.6, negative 0.5. So that's what averaging is going to do for you. It's going to both reduce the number of samples and it is going to change the signal. And in changing the signal, it has removed amplitude associated with the higher frequencies. Not completely, because as I zoom out, you can still see a bit of the signal there. So the value that you're going to use for averaging is going to depend on what you need. We should look at the data file, and I've created the data here. So this is the separate and average. The first one I did before I started recording, just to make sure the worksheet was still working. So if we look at this data file in Excel, so if we bring this data file over, all right, so I want to format these cells and I want to show time, and I use a custom time. So I'm going to use hours, minutes, seconds, .000. All right, so now you can see that I've got the data every 10th of a second and that it's changing slowly. But the main thing I wanted to show you was the timestamp. So 000, 001, 002 in the fractional seconds. So that was the full speed data. I am going to open the third file that I made and do the same thing with formatting the column. And I'm using hours, 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 minutes, minutes, seconds, seconds, dot, 1, 2, 3. And now you can see that this data is being stored every tenth of a second. So instead of being 00001, it's 100, 200, 300, 400, 500. So I have reduced the total amount of data that's being stored using an average function. I'll close that, get that out of the way. So the next thing to do is to compare that to how does it look with a separate.
The separate module allows you to reduce data without distorting the data. When you average data, you are doing a computation on it, and the outgoing data point doesn't look the same as the incoming data points. With the separate module, we don't touch the value. All we do is reduce the total number of values. You can separate by block. You can keep one, throw away 9 blocks. So you'll have a huge gap between blocks of data. Or you can reduce by sample, and this downsizes the sample rate. And you can do the same thing. You can say, I want to keep the first value, throw away 99 values, keep the next value, throw away 99. And that would reduce your sample rate by 100. If you're working with FFT or histogram blocks, again, you want to separate by block rather than by value, because then you would distort the FFT information.
And I will do that by adding a separate function. Do the same thing, 3 channels. I want to do the same kind of thing, but the terminology in this module is different. In the case of average, we said we want to keep one for every 100. And in separate, to say the same thing, I need to say I want to keep a value. And initially, I will keep the first value, so I'm not going to skip any. And then I am going to skip 99. So I'll keep 1, skip 99, and I'm going to change the block size to 1. This is the same type of module bar as above all the settings. So all the settings below, I'm sorry, the channel bar. This is the same thing where the channel bar is above all the settings. All the settings underneath the channel bar apply to only the channel that I just configured. If I look at channel 1 or channel 2, it's still at the default settings. So I'll go back to channel 0 and I'm going to click F8 again. F8 works really well in modules where the channel name gets copied. So in this case, separate 0 is the grayed out channel name, but it doesn't matter because it will pick up the channel name from the channel. So all the settings are the same now. Click OK, and I'm going to put it where the average module is. So I'm going to delete the average module, replace it with the separate module, wire that up, and just make sure, I'll do copy channel names, restore the displays, and click Start. So this is still separate and average. It's going to be the next file. I'm up to file 4. And so what I've got is I'm keeping 1 in 10. And let's zoom in and look at this data. I've got something that looks a bit like a sine wave, but it's choppy. This is a 60 frequency, 60 hertz signal coming in. If I reduce the frequency down to about 6 hertz, then I'm getting a very clean signal. I haven't lost much data at all. I'll go back to the 60 hertz. and increase that. So I'm losing the frequency, the sense of the signal, because now I'm undersampling by removing 1 in 10, but I'm still getting a sense of the maximum amplitude, not so much the frequency now. We've distorted the signal a lot by undersampling it. So I'll go back to a lower sample rate, and now we're getting a waveform that at least gives you an idea of the frequency and the amplitude, even if it isn't nice and round. Go back to something slower. And oh, isn't that nice? We get a nice squawk. Go even slower and get back to the sinusoidal waveform. So what separate is doing is removing samples. Now if I click on the wire coming out of the separate module, the block size is 10 and the sample rate is 10. Why is that? There we go. The sample rate is 10 Hertz and the block size is 1. Going into the separate module, the sample rate is 1,000 and the block size is 10. So this is the difference between separate and average. Average is computing on the data and producing a signal that is an average. Separate simply removing samples. And at slower frequencies for this separation, you can't see anything. At higher frequencies, you start to see how the removing samples affects the signal. In this case, it's removing enough that instead of looking like a simple sinusoidal waveform, it's looking like a squawk type signal. I'll click stop and we'll look at the file again. This is average 4. I will open it. And now I need to modify the timestamp again. Custom hours, minutes, seconds, dot 000. And click OK. And so now I'm doing the same thing. I am saving the data every 10th of a second. So that's reducing data. I've reduced the data by 100 in 2 different ways, just to give you a sense of it. Now, one of the things that I mentioned was that the separate by block or the block average does something completely different, and we can do that. I can change that dynamically. Let me edit the separate module and change it to data blocks. So I am going to keep 1, ignore 99, keep 1, ignore 99. I have to make this setting for the entire module. So I'm going to click F8 again and double check that data blocks is the setting for all these things. All right, so now how is this going to look? Let's unzoom this and click start. So this is separate blocks and click start. So the chart recorder doesn't display data until it's got 2 blocks. So that first block of data that it's got is sitting there hanging and waiting for the second block to come through. And then they both displayed at the same time. And now moving forward, each block is going to display in turn. So I'm keeping a block in every 100. And so the initial block was clearly a sine wave. And let's scroll over to find the next block. The next block has clearly got the sine wave in it. So what we're doing is we're getting a fragment of the sine wave periodically. And then we're waiting for the next one to come through. So let me zoom out again. So now I've got 6, 1, 2, 3, 4, 5, 6 have come through while we're talking. And if I zoom right into it, you can see that that's an intact waveform, but there's a huge gap. So separate by block, kept a block through A99, kept 1 through A99. Let's look at the data associated with that now. So I have a new file called separate blocks. Let's open that up. Let's fix the timestamp. Let's fix the timestamp. Custom. So I am looking at this, and the first chunk of data that I'm looking at, we're at 30 seconds. And then 100 samples in, we jump to 40 seconds. 200 samples in, we jump to 50 seconds. So this is every 10 seconds, I am storing 100 samples. And then 60 seconds is back to 0, 0. Okay, going back to the worksheet. That was just a quick illustration without talking about the merits of these different things. Why would you do a separate by block rather than by value? And separate by block is not downsampling the data, it's just removing a lot of data. One of the reasons to do that is if you're doing FFT computation. This is an intact block of data that the FFT can do the computation on. And then 10 seconds later, it will do the next computation, and 10 seconds later, the next computation, instead of doing a computation for every block of data. Same thing with the average module, except when you were looking at the average module, there is, instead of doing it all in the average module, we have a block average module. And I'm just showing you this without putting it in. The block average module averages across blocks. So every block position 1 will get averaged. So this is set up for 4. The output of this module will be a single block for every 4 blocks, where each position of the block has been averaged. So they're not averaged by time, they're being averaged by position in the block. And the output will be a full block of data. You can do an arithmetic mean, a maximum, minimum. You can do it by block, cumulative, and you can do it with a restart. All right, I'm going to remove that from the worksheet, and we will save this as a file so that we can go back and look at it later if we need to.
I'm trying to keep these videos about an hour long, so Module 7 will continue in the next video.